Class, welcome back to CSC 143, Intro to Data Structures. We are in week 5 using chapter 11 of the Building Java Programs book on Java collections. And this video is on the start of the chapter, section 11.1. Just a brief reminder that 142 and 143 are University of Washington curriculum, taught at all the Washington State colleges. It's basically an Intro to CS course, and we use the book Building Java Programs, 4th edition, and you can get it at this website for $35 online, so you don't have to actually carry around this huge book. And this is the second half of the series, Introduction to Data Structures. If you haven't already taken 142, you should definitely take a look at my videos for that. So this week we are going to be looking at Java collections. This video is about lists, so it's going to be covering linked lists versus array lists, the iterators, and the abstract data types, which are called interfaces in Java. The slides I'm using today are produced by my good friend and of over 30 years, Amelia Gahn, and these follow the book fairly tightly, so you should be able to follow along pretty easily. So this is chapter not 1011, but this is binary for chapter 11. And let's get started here. So we're going to be talking about the Java collections. And Java collections it's a generic term. We're not actually going to be using collections very much. It's pretty rare you're going to be using the term collections, but it's a generic name to say that it just stores some things. Collections is actually a Java interface. So we learned back in chapter, I think 9, that interfaces are generic classes, so that they have functions which have not been implemented, and so as long as you have a class that implements certain functions, you can call it, you can meet that interface. So collections defines a bunch of functions we're going to take a look at in a second. One example is an array list, so we just looked at that in chapter 10, and collections use various different data structures and categorized by the types of elements. We're going to talk more about how we categorize the different types of Java collections. Here's the examples that we're going to be looking at in this chapter. So list, we've already taken a look at an array list. We're going to be looking at a linked list here. We're going to be looking later in chapter 12, I think, about stacks and queues. And this week we're going to be looking at sets and also maps. So we're just looking at a subset of the collections. There are more Java collections classes that you can look at online. Everything in here is a collection interface except for the map. So here's some of those collection interfaces. So if you have any data structure, you go out and create your own data structure. As long as it implements the collection interfaces, you can use it as a collection. So this is not a full list of all the features, but your collection has to be able to do things like add a bunch of elements, clear out the elements, remove a single element or all, remove everything in this collection, find out whether it contains an element, tell you whether it's empty, and give the size. This is a map. This is a fairly important map, not the most important map, but this is a map on figure 11.1 in the book. And this is showing you that there's two collection interfaces. The collection interface is the one we're mainly talking about, and so you cannot instantiate a new collection. Okay, you have to actually instantiate a new array list. This is an implementation. This is an interface, and lists and sets are also interfaces that implement the collection interface. And the array list and linked list are both list interfaces. Hash sets and tree sets are both set interfaces. And then separate from the collections, there's the map interface, which is implemented by a hash map and a tree map. And we will get down to explaining each of these different things and why they're different. And I'm also going to show you a chart of how you figure out which of these different data structures you're going to use, along with a couple of other ones we've already learned, like arrays. I think that's actually the most important part, but I don't want to get there yet. So first we're going to talk about array list versus linked list. So in chapter 10 we talked all about array lists. They're basically just arrays that you can extend. Linked list is similar. They both perform similar functions. You can treat them similarly, but they are actually fairly different objects, different classes. So the main difference is that when you have an array list, it's a contiguously allocated array, just like a regular array, except the array list can be expanded. And if you want to add something into the middle or delete something from the middle of an array list, it can be done, but it's laborious because it has to shift a whole bunch of items. Later we'll learn about orders of algorithms, and these algorithms are very expensive. They tend to be order n squared algorithms. So when you remove an item from an array, you have to shift a whole bunch of stuff. A linked list doesn't have to do that because it stores items with individual pointers. So it's easy to change pointers around and insert an item. Here's an example. So between each item, instead of it being contiguously allocated in an array list here, and we can just use a calculation to figure out what's the fifth element, these are separate elements. They could be anywhere in memory, even though we draw them next to each other. And they have a pointer to the next and a pointer to the previous item. And this allows you to insert an element in the middle just by changing the next pointer from here and changing the previous pointer from here. And actually, in a future chapter, we're going to be studying an implementation of linked lists. And that's really where we'll spend most of our time learning about linked lists. We're just kind of introducing it in this chapter. So there are some list problems that we'll get to in practice it, but we're going to move on to the next topic now, which is iterators. So one thing the book doesn't talk about much is that you probably remember the for each loop, where you have for open paren string colon s. Okay, that'll loop through all the strings. It would be string s colon of my strings or something, and that would loop through all the strings in an array or something like that. And for each is actually implemented with an iterator. The big limitation with iterators is that with for each is you cannot remove something or add something while using a for each loop. And iterators is going to get around that constraint. It's a little bit confusing because if an iterator implements for each, why can't you delete things with for each? And it's just this little quirk in how Java does it. For each is what we call syntactic sugar. That's an actual computer science term. You can Google it. And it just means that when you write for each, it actually translates it into iterator code. But it doesn't expose the actual iterator because it's just syntactic sugar. And you can't, therefore, delete things. Yeah, probably went over your head. It's okay. Just trying to explain to you that iterators and for each are the same thing. Some people incorrectly think that iterators are more efficient than for each. That is not the case at all. They're definitely the same thing. All right, so unlike arrays, linked lists don't provide fast random access. So if I want to find the fifth item here, boom, it's easy. If I want to find the fifth item here, I actually have to step down 1, 2, 3, 4 different pointers before I get to it. So it would be nice if we wanted to walk down this list, an array list, it's very quick. When we walk down a linked list, it's not very quick because every time we try to get the ith element, we have to step down I elements. But an iterator gets around that. An iterator is basically a pointer that hangs around that points to each of these. And so we get this item here, and then we go and do our work, and then we use that same iterator and we ask for what's the next item. And then it just hands us this one without having to look up all these previous ones. So it's got a next and a previous reference on linked lists. We're still talking about linked lists. Let's get over to here. Here's the format of the iterator. So if you have a list, you can call list.iterator. That's actually supposed to be open paren, close paren there. It's a method. And here, I can fix that. No, I can't. So iterator is a parameterized data type, so you have to tell it what the iterator is over. So for example, if it's a list of strings, it would be iterator string equals list.iterator. And then while has next, so this should look a lot like the scanner code that you're familiar with from 142, then you can do something. And be careful, I'll mention this later, but you only want to call iter.next once, because if you call it multiple times, it's just like in the scanner. You're actually going to pull multiple items. You're going to move down that list okay? And you're never going to be able to get back to the previous item. Yes. Operations do not change the value stored in the list. So this statement is actually not correct. I think what Amelia was trying to say is that if you iterate with strings, that it's not going to work because strings are immutable, and if you copy a string, it's just not going to work. But I just verified that if you create your own object or use an object like a point class, and you have an array list of points, and then you iterate through the points, yes, you can absolutely modify those points. So yeah, this is not true. They do, in general, change the value stored in the list. Here it says that LinkedList has a remove method. It can be inefficient, yes, because it is, well, actually, LinkedList removes are not going to be inefficient because they have those pointers. Let's go back. So when you remove this item here, it's not inefficient because it's just going to have to reset a few pointers here. The big difference between the advantage of using iterators is that you're not going to get the concurrent modification exception for removing of the iterator. But if you actually try to use if you use the linked lists iterator itself, it will give you a concurrent modification exception. But if you use the iterators remove, it will not give you a concurrent modification exception. But if you do try to add, then that's a new item, and so it's not going to be allowed. You're going to get a concurrent modification exception. Okay, so I'm not going to talk about the list iterator. That is a thing. And this is just very much like the scanners. So remember when you have has next for scanners, you don't want to call next and then next because you lose this next here. Same thing with the iterators. Okay, you want to store that next, or if you can just use the has next, that's fine. But you don't want to call iterator multiple times. So let's review this. Array lists are just arrays that can be expanded. They have direct random access that are very quickly accessed because it just uses a computation to figure out where your item is. Removing, adding at the end of the list is fast, assuming that, well, in an array list, adding to the end is always relatively fast. You might actually have to expand the list. Removing from the end of the list is also relatively fast. I don't know if it ever shrinks the list or not, but those are good things for array list. Linked list, if you want to add, so adding and removing at either the beginning or the end of the list is fast. You should be actually, let's see what else she says. Removing during a sequential access with an iterator is fast. Yes, that's true. Unlike arrays, there's no need to expand it when full. That's true. There can be more easily used as a queue than arrays. Yes, that's true. But I would say that adding and removing anywhere is fast because everything is pointers. It doesn't matter where it is. At the beginning or the end, it doesn't matter. I think she must have meant to say that anywhere besides the beginning or the end, it's fast. Okay, abstract data types. So in general computer science, we have a term called abstract data types. What abstract data types translates to in Java is an interface. So an abstract data type is just a definition of a whole bunch of behaviors of an object. Okay, and so Java uses interfaces to declare that, and they're generally parameterized interfaces where you have to say linked list of string, linked list of integer, for example, and yeah, so that's what an abstract data type translates to in Java. Here it's suggesting that when you create a new linked list, you don't assign it to a variable linked list, but you rather assign it to the variable list. This also applies more importantly to the returns. The reason why you want to do that is on the next slide, because if you later want to change your implementation from an array list to a linked list or whatever, then you can just do that and it's not going to change the return type, or it's not going to change the variable, and you have flexibility of implementing a change. Whereas if you return or you have a variable of a linked list type, then you're stuck with linked list. Otherwise, you're going to have to go in and change every single occurrence. So you really want to try to use these abstract data types. or I should say, yeah, they are abstract data types. It's also an abstract class. So list is the abstract class of ArrayList. So you can't do a new list. You can only do a new array list, okay? Because list is the interface, whereas ArrayList is as the actual class you can implement. Let's see, what else? So yeah, it is possible to not even use the list, but you could use collection, but I really don't recommend doing that. There are a couple of things where you might want to use it as a collection, but you really shouldn't. So there's also, in addition to the Java collections, there's a specific class that's actually named collections. And we've had a couple examples of this type of thing in the past, but it's pretty rare. So collections has some useful features. One that isn't listed here, which I actually think is the most useful, is sort. So collections.sort will allow you to sort a collection like an array list or something. And other ones here, they've got a binary search, copy, max, min, reverse, swap. So the page 711 isn't correct because of the 4th version either. So if you want to use one of these features, you actually have to say collections, capital collections, dot sort. Okay, and so that's not using a collection as the interface. It's actually using a special Java class called collections. There's a corollary to that is there's an arrays class you may have learned about where you can do arrays.asList or things like that. Again, they're pretty special cases. All right, so we'll deal with sets in our next video. So this ends the video on lists. Now let's take a look at a couple of problems from Practice It and see how we can apply this. So there really aren't a lot of Practice It problems for lists, but I'm going to point out a couple of them. This one is called alternate, and you're going to take 2 lists as input, and then the output is a new list. So first of all, you're going to have to create a new list. Is a new list containing elements, alternating elements of the 2 lists. And whatever list is longer than the other, you're just going to stick the rest of those items onto the end. So it's pretty straightforward. What they want you to do, I don't remember if it actually says it in here, but what they want you to do is to use your iterator. Okay, so you want to create an iterator on the A list and iterator on the B list, and then while there's an element in either of those lists, you want to take one item for one and one item for the other. But you have to check whether one of the lists is ended. If one of the lists is ended, then you don't want to take it from it. But it's a good exercise. It'll help you get used to the methods for handling lists. Here's another problem, remove in range. So we're given a list, we're given a value to look for, we're giving a start and ending index. And so in this example here, these are the items that fall between that start of 5 and the end of 13. And we're supposed to remove all of the zeros from this range. So you see the 00204, but then the 0 is removed before the 6, the 0 is removed before the 8, the 0 is removed before the 10, before the 12, and then I guess 13 must be, I must be off by 1 here. And then we leave the 0, the rest of these in here. So this is pretty straightforward. So what you need to do is you need to skip past the first elements before you get to this index. And you're going to use an iterator just like before. You should have an iterator over the list elements. You're going to have a loop to skip past a certain number of early elements, and then you're going to loop until you get to this last element here, and if there are any values that are equal to this, you're going to use the iterators remove. So don't use the lists remove, but use the iterators remove. And the reason why is because if you use the lists remove, it can throw a concurrent modification exception, but the iterator is not going to have that problem. So that's the only other list problem, but I think that should give you a little bit of training. And again, we're going to spend a lot more time with linked lists in a future chapter. So that's the end of this particular part of the chapter. If you appreciate the video, please like and subscribe, and come back to get a section 11.2 and 11.3 on sets and maps.